Welcome to today's Ascendo Reliability webinar. This is Fred Schenkelberg, and thanks for joining me this Tuesday. I think it's Tuesday for many people around the world at the same time. Had a quick chat with somebody from Tyroione. I'm sorry, probably not pronouncing that correctly, but welcome and enjoy your spring day, even if it is indoors. I'm, as you have noticed, if you've attended any of these webinars in the past, is that we're moving over to Zoom. And it's really so that we can have the chat window. We were using GoToWebinar there for a while, and it only had the Q&A tab and it didn't allow you to chat and see each other's messages easily. And it was a bit of a pain doing the workaround. So we're moving to a new platform. So hopefully it all works out. All right. So let's see. I think I've got everything going. And oops, I actually have to put my cursor in the right place. There we go. Now, risk and risk management, in my opinion, has been a part of reliability engineering. It's just what we do. It's just in a part of dealing with reliability of products or systems is dealing with uncertainty. And to me, risk is synonymous with uncertainty. And it's dawned on me over the years, and as more and more emphasis in literature and standards are shifting to to risk and risk management, is that one of the things that we've always been doing is dealing with the uncertainty of, say, a failure rate, is that's expanding. And that's what I hope to talk about, or am planning on talking about today, is our relationship with risk and risk management, and then risk management in a larger context than just dealing with product reliability, and how we are well suited to assist our organizations in dealing with uncertainty inside a reliability management program. Now, of course, there's tons of questions when it comes to dealing with uncertainty. And there's questions of what can we do to understand what could go wrong? And we do that pretty naturally as reliability engineers, as we ask the questions, well, how can this fail? Or what will fail? We ask those kinds of questions all the time. A part of a risk management program is constantly looking around for what could go wrong, and then naturally then what to be the consequences if that happens. And if that reminds you of an FMEA, well, that's one of the many tools that we can use to both identify and to analyze the types of risks that are posed in our organizations. Now, FMEA has been a part of reliability engineering as long as I know, and it's part of a process that we can use to help the rest of our organization. One, ask the right questions, and to help find good answers for those as we go. The other part of what makes risk management so tricky is that it's really aimed at the future. What we're looking forward to is, given the current state and circumstances that we find ourselves in today, and with the signals and information and trends that we have available, and our knowledge of both the market, of customer behavior, of uh, just all the different elements that are at play, what can we estimate the future is going to be? Now, as you know, and listening to the daily weather forecasts, is sometimes that's difficult. Um, but sometimes we have a pretty good idea, and then we can evaluate what are the signals or trends we should monitor in order to understand, well, which future is unfolding. What are the elements for us? And we do this pretty naturally as reliability engineers, as in prognostic health management type work, or in looking at field failures, looking for trends or new types of failure mechanisms that are occurring, and what's that future pattern going to look like. We kind of already do a lot of risk management, and I think that's going to be an underlying theme for me as we go. All right. So here's a question for you and a chance to exercise your keyboard a little bit with the chat window. Is there, I mean, in reliability engineering, I know many of us, both in asset management work and in plant operations and in product development and getting systems to the field, we deal with failure. And a lot of what we do with reliability engineering is focus on failures. Our system or product or item doesn't work as expected, or it fails to boot up, for example, things like that. Yet I suspect that's not the only risk that's out there related to what we do as reliability engineers. So what's your thought on this? What other types of risks are out there other than, say, a failure, a product failure, or a breakdown? Yeah, Rod, over engineering. I find that difficult to do, but it can be done in rare occasions. Um, it certainly is a risk. Injury to humans, and the injury to people or harm doesn't have to be a failure. Our product can be inherently dangerous by its design, and it could be functioning just as it's supposed to. That's true. Um, Safety, certainly, and we know how that works with our usual reliability engineering tools. Uh, Brand or reputation, those kinds of things, launch, slip, market loss, right? Um, yeah, good. All kinds of good stuff there. Now, part of it is that, and we often see an organization is developing a product, or at least I've seen this number of times, and they do a whole slew of last minute product testing to make sure they're ready to launch. And then they find some catastrophic failure and it delays the program. Yet there's still, um, it's still based on a failure being found. Now, some of the work we do is try to ferret out all those things that can fail as early as we possibly can in order to mitigate that chance of a delay to the program, the consequence of a delay. The risk also apply, as many of you were mentioning, much more broadly. Now, one that I didn't see here, and it's related a little bit to loss of reputation, is what about the risk to the consumer? What if your product performs as it's expected to do, right? It meets all of the internal specifications, the right weight, the right throughput, the right whatever. Yet the marketing set an expectation, or the customer had an expectation that it was going to do something else, right? That's not really the product failing, but it's a larger failure in the system of setting expectations and meeting customers' expectations. And we might point at marketing, we might point at customer misunderstanding, could we all point to all kinds of things. Yet there's a real risk that we could get exactly the product we intended to make, but miss the market and just not be functioning. Now, do we call that a product failure or a business failure? To me, it really doesn't matter. If it costs us money, right, then that's a problem and then something for us to deal with. So it's one example of how risk is not contingent on a product or a system failing or failing to perform. It's contingent on what's the uncertainty. And it can be from business point of view, it could be from a market point of view, it can be from a supply chain point of view, and so on. And so let's explore this a little bit deeper. Before I get into more of these concepts, let's define a few terms that are a tip of the iceberg, I should say, of the types of terms that are floating around with risk and risk management. Now, I briefly defined what risk was, and I basically it's the potential for to me, it's uncertainty. I would just erase risk and put in the word uncertain. The idea is that you have some potential unwanted outcome, right? Now, it can be that you have a product failure and you fail too often. Now, it can also be that the failures in your product are too low. I actually ran into this when I was working at Hewlett Packard. We had a couple of organizations that, picked up on the design for reliability. They did all the right things, but their finance team was more conservative in setting the warranty accruals. And so they set aside more money than they actually needed to manage the field failures that were occurring, and the fewer that were occurring, the few that did occur. And it caused them to underreport their profitability. And I thought, well, that's kind of a good problem to have, right? You got more money than you wanted. And no, one of the finance folks told me, he says, no, we set aside, $100,000 or whatever the number was, and didn't use it for an investing or to expand our product offerings or to hire somebody or do whatever. It was lost opportunity. And so that has a real cost. And then in a larger context, what we found was that the inability to predict the warranty accruals correctly caused the biggest share of missing investors' expectations. If we said we were going to make $1 per share and we made 80 cents, the market doesn't like that. If we made $1.20, the market also doesn't like that. And so the biggest reason for that variability was inability to predict the future failure rate and the warranty accruals. The risk can go either way, right? It can be an unexpected good turn. So let's say our product unexpectedly is accepted by the market and everybody wants to buy one. It's the new holiday must-have gift kind of thing. And it was unanticipated. There's an uncertainty about, well, what's the market acceptance going to be? And now we have a real risk of how do we ramp up? How do we bring on more suppliers? How do we meet that upside challenge versus the downside challenge? And so risk can go either way. We often think of it as the unwanted harm or bad things that happen and the consequences that come from those events. A risk event, I should add, is that occurrence of a set of a trigger is what I call it. Is it's the instance that causes the risk to manifest itself, to go one direction or another, to that uncertainty becomes revealed, and sometimes that trigger gives us enough head time that we can do something about it and respond to it if we're looking for those events that are occurring or as they're occurring. Other times the trigger and the consequence happens simultaneously. Somebody in the chat mentioned catastrophic failures. If that happens pretty quickly and there's no foregoing warning prior to it happening, well, especially when you have a high severity type thing and there's no detection available, I'm using FMEA type terms, then that's a risk that we probably want to know about and deal with. Now, it brings up the concept as well, there's always risk. There's always going to be some uncertainty in anything that we do, not just in reliability work, but bringing any product to market or firing up any production line or even walking across the street in some parts of the world. Well, many parts of the world. Well, what's an acceptable risk? Now, that, as you know, varies. And I use the analogy of the airline industry having the data to show that it's safer traveling by airplane than it is driving, right? There's so many passenger miles or hours or whatever, how they actually measure it. Yet the acceptable risk for an aircraft failure that destroys the aircraft and loses the plane crash basically is incredibly high compared to what's the acceptable risk for, say, a smartphone or for your automobile. The acceptable risk is relative to that market, the society, and what your leadership, your decision makers find to be appropriate. And it you could be two automobile makers and one will have a different acceptable risk level than the other one. It That's one of the floaty things that I find very difficult to pin down. Yet when you're working within, even within reliability engineering work, and you find something that's going to cause a 1% field failure rate. Now, is that a trigger or an event, a piece of information that says we need to do something about that? Or are you in an organization where a 1% failure would be a really good thing and then it'd be, perfectly acceptable? And so the point is that when we do our work and we find uncertainties, we find a problem with a supplier and they may not be appropriate to send parts to us anymore, for example, is that, do you have a way to know where's the uh, event horizon, I should say, or what instigates you reporting that? And part of that is knowing what the acceptable risk is within the organization. And so that's why I listed that term. And another piece here, and you're seeing more and more of this in different ISO standards. The ISO 31000, I think it is, 31000, is essentially a risk management framework. It outlines, and it's very similar to a plan, do, check, act type process, is, what here's how we report, here's who does what, here's the types of activities that help us identify, analyze, and mitigate failures. And then there's, like most ISO processes, it also has a check step saying, hey, did we do okay? Did any part of this process fail to meet our expectations or requirements, and how do we improve it? And so there's a number of different frameworks out there. ISO 31000 is one that I'm vaguely familiar, roughly familiar with, and I know that there are others. Yet it's basically a structure within an organization that lays out what's our plan? How are we going to go about managing the risks that are all in front of us? And then how do we fit into that? When it goes to an entire organization, you might see the term enterprise risk management. And so it may be at the board level, or the C-suite folks are talking about risks to market acceptance or portfolios or all those kinds of things. But then how does that all work out? How does that manifest into changes in priorities and emphasis? Where do we work to understand the risk and manage it? And then vice versa, as we're working in as an engineer, and what's our role and responsibilities to identify risk or to report elements that we see? Now, that's all within a framework, and we'll spend a little bit more time on that. Another element here is risk appetite. And the analogy here, the way I define it, is related to, say, you're investing. Some people are very cautious and they'll invest in very safe and secure or insured type activities, like a banking account with some interest, or a government bond, for example. While others are more risk accepting and they'll take on, say, startup funding or venture capital or very speculative type activities. They have a bigger chance of losing their investment, but they also have a bigger chance of earning more. And that, again, the risk appetite is our individual um, acceptance of what's okay and not okay when it comes to uncertainty. How much uncertainty is okay? And it goes back to, within the organization, is understanding what is that acceptable risk? What's the level that we're going to be okay with and need to do something about? And so within an organization, that's part of the culture. It's part of the discussions. It's part of the ongoing work. And you can test this real quick, is go ask, 3 or 4 people that you respect, saying, if we have this circumstance, does that mean we need to do something about it? What about this kind of circumstance? Something that's either more or less risky. And part of it is to make sure that you understand what's the types of things, the types of uncertainties that you need to deal with. So going a little bit beyond just terminology here, but I wanted to make sure we understood some of these things. And it's part and parcel of what we do as reliability engineers, but it also is a much larger world that we can work into. And so risk management, um, and I mentioned risk management plan and these frameworks and everything else. When it comes down to is basically you take one of these frameworks, like the one from ISO, and within the organization, and it goes all the way from the CEO and board level folks to everybody in the organization, should be aware of a risk management plan. And it includes things like who can talk to the press if there's a major field disaster or major problem, uh, who's got the ability to speak for the organization if the news cameras are start rolling outside your door. Hopefully that doesn't happen. But part of it is who's responsible for identifying problems, who's responsible for prioritizing which ones we need to deal with and not deal with, which ones need to be reported and to what level, who can make decisions on different levels of risk at different types of risks that are out there, and so on. So the scope is very broad. It covers business risks and market risks and supply chain risks and all of those other elements that go into creating products and systems. And you can immediately see, I hope, that what we do in reliability fits into that very, very well, right? Because we work with designs, we work with suppliers, we work with manufacturing, we work with field data and or customers in their products in the field. And we have this view across the life cycle that very few people in the organization actually have at the details that we commonly work at. And so part of that is we often are the first people to see a, a recall type event starting to occur. And then well, how do we know when and how to escalate that? And then who do we escalate it to? Right? Is this worth waiting till Monday or do we have to do it today? Or should we wait for more data or is this worth reporting today? So part of the risk management process is having within an organization a very clear structure that's built into the usually within the management programs um, and oversight programs is to have many of these questions related to what's our risk um, appetite, what's our acceptable risk levels, who is supposed to do what and when. Those things should be fairly well spelled out and as we fit into these larger programs. Right. Now, as reliability engineers, right, this is what I've been talking about, is that it's oftentimes we trigger off of failure rates. If our product is really supposed to have a very low field failure rate over a year, and we find something that's going to cause a 10% field failure problem, and we have evidence for that, that's easy. But what if we're at 1.5%, right? What's our responsibility there? When do we trigger and when do we alert the rest of our folks? But more importantly, as we're working through the design, supply chain, our branding, working with marketing in some cases, understanding what customers' needs are and consequences of failures or of our products performing or not performing as it should, it gets us beyond failure rates, right? So as you know, supply chain issues can be disrupted for political reasons. And now we have a or natural disasters. Either one of those kinds of things are real risks. And what's our ability to identify those and the impact of those, and then make appropriate decisions as the supply chain is built. Now, reliability engineers may or may not be involved with creating the supply chain. We sometimes get involved only when there's a problem and a vendor's parts are causing field failures. Yet I think, as you know, my opinion is we should be involved early on in the supplier selection so that we get components that are from suppliers that create a reliable component that fits within our system and is stable. I'm thinking of SPC here, the statistical process control and process capability. So our ability to influence supply chain is pretty broad. Understanding the impact on brand and on the customer's consequences, it helps strengthen our arguments to make improvements. So those are all bits and pieces of how I think about um, uh, uh, risk and risk management. I think I already answered this question, but um, no, they're not all bad. Risk is really just uncertainty. We don't know what the outcome is going to be. So let's explore a little bit about the process, right? Um, I mentioned it in passing earlier. It's basically three pieces to it: risk identification, analysis, and then mitigation. And it's an ongoing, happens all the time. We got to work with it, right? So part of what we do in reliability, and I've mentioned this a number of times, is we deal with failures. It doesn't perform as it is expected to perform, or it doesn't start, or it just doesn't perform correctly, or it degrades. Many of you talked about these kinds of things that are parts of the risk. And we are pretty much working most of the time looking at how do we design out the possibility of failures, how do we make it more robust, how do we build a production line that creates a consistent product that meets the requirements, and all with the aim that it will create a product that performs as the customer expected it to. And so part of this is that we need to look at both, the failures. That's fine, but keep in mind that if something's performing too well, is start thinking about the financial risk of setting aside too much money for that. It's one example where what we do in failure, in looking at failure rates, impacts other parts of the organization. We may just not know if it's a good or a bad outcome, and what's the span, what would trigger or instigate one or the other of those types of things. So how do we use what are the risks are, and looking not only at what we're working on, our design for reliability type stuff and our creation of a supply chain and so on, but as I mentioned earlier, is the things like tariffs or uh, uh, natural disasters or changes in the marketplace. While we may not have all of the information to do that, we certainly can ask those questions. Well, what happens if it's part of this risk identification process? What if our key supplier um, has an earthquake and their fab is shut down, their facilities are shut down for 3 months? What's our recourse? Now, the chance of that occurring is pretty low, yet the consequence is pretty high, and that's a risk identification process. So let's understand that it could occur. Now, you can obviously think that there's going to be a lot of brainstorming going on here and some discussions and so on. But part of it is in a risk management framework is one of the things they encourage is setting up an ability to consistently scan, is to constantly be looking for the parts that you don't know, right? It's easy to understand the risks that we do deal with day in and day out, but it's those risks that are completely out of left field that throw a wrench in a lot of things. And I think, thinking of COVID-19 for many of our businesses and the way we work is one of those that wasn't anticipated broadly, except by a few people that have made the point of, well, I told you so. But the idea is that how do we identify that full suite of types of risks that are going to impact our products? Many of the tools that we use uh, in reliability are the types of tools that work at a larger scale across internal, external sources and in an ongoing, consistent way. And so part of the process is to think broader of the range of type of risks that can impact the performance of our products and our systems. And that's the identification part of it. And the hard part for most people is doing this ongoing, to consistently do it. It's like doing an FMEA, right? You do it once and set it aside. No, the intent of the FMEA is to do it in an ongoing way. And so the analysis part is really, to me, is two parts. One is that we understand what are these risks? What is the actual, um, uh, how does this uncertainty unfold? And what range of consequences can come out of this? And what kind of probabilities are there? How do we know the range of different potential risks that are facing us? And then how well do we understand them? And so part of it is just understanding what's out there, the identification process. And then once we say, oh, there could be an earthquake where our key supplier is, well, what's the probability of a significant earthquake taking out that plant? That's part of the understanding step, is getting the data or the information necessary to appropriately assess the the frequency and severity of that particular risk. The other part of then is priorities. Once we have collected and understand the types of risks that we're facing in the range of risks that we're facing, is that's where FMEA and other modeling tools and hazard analysis, things like that come into play to say, which ones do we need to address? Which ones are acceptable? And a pretty nice tool is this risk matrix thing. Let me see if I can get is this risk matrix tool. And I wrote an article on this not that long ago, but basically I think it's occurrence and severity is one way to set this up. And you can have 3x3 or 5x5. There's all kinds of different flavors of this thing. But then when something occurs very frequently, let's say this is higher occurrence and higher severity, and you could use probability and consequence is another way to do it, then let's call this a very high risk. So something that lands in this red box is something that we're going to prioritize and deal with. Now, sometimes things, they might have a high severity, but a very low occurrence. And you may, as an organization, decide that those kinds of things fit into, well, when we get time, we'll deal with these things. A lot of people put red across the top severity all the time, but it's one of these classic management tools, right? Red, yellow, green. I think that's green. And so it becomes a prioritization tool. Now, if the organization is doing this in a ongoing way, in a regular routine way, you could update this on a regular basis as conditions change, as information changes, as your understanding changes, the priority may change also. And it's a step in the analysis is to set priorities and to communicate it. And the risk matrix, along with FMEA and all the other types of tools we use to prioritize things, and failure analysis and all the tools we use to understand the types of risks that we're facing, then we can communicate a broad range of risks fairly quickly. And that's a good thing. Oops, I'm learning here about drawings on Zoom. So I haven't talked about mitigation very much, but that's really one of the things we're going to talk about in more detail. Which risks in your organization always get addressed or mitigated? And I think I know the answer to this, but I want to double check. Plus get a sip of water. Yep. Thanks, Evan. Yeah. Safety risks, human safety. Now you can also lump in, catastrophic loss of capital or environmental parts. I think many organizations include those in the highest severity things. And it's, if you're doing an FMEA and you get a top score on severity, most practices of FMEA then say you need to address those high severity things independent of their occurrence rating or detection ratings. Is how can we reduce the consequences, even if it's something that's very rare? And that goes back to that acceptable risk kind of thought process. But within each organization, vast majority of organizations consider the loss of life or harm to people or harm to the environment, harm to to society in general, are things that we tend to always address. But then it becomes, at some point, it's a gray line. Do we address this or not? And that goes back to that acceptable risk concept. Okay, so let's talk about mitigation a little bit. There's a couple, if I remember right, there's 4 basic approaches to mitigating a risk. And one of them is avoid it. If you can, if you think getting on an airplane and traveling at this point in time with the COVID-19 and all these other things, even if the aircraft travel itself is safe, um, the and I have no idea, no data on how much the transmission rates are within an aircraft. I think the aircraft organizations are trying to say it's actually safer in the plane than it is in the terminal. Um, but the idea is that one way to avoid that risk is just don't go on the plane, right? Just cancel that project. So if you are designing a product and has a large amount of uncertainty and downside risk to it, one way to avoid that risk is just don't do that project, right? In other areas, it might be parts of your market. Let's say your product is susceptible to serious degradation when high humid environments or high temperature environments. Well, if you don't sell your product into those markets, you are avoiding that risk. All right. So part of the process of mitigation is understanding the profile of risks that are available to you as you start to design or build a program or a product or a system. And one of the least expensive ways to avoid those risks, those uncertainties, is just don't go there. That may seem kind of trite. We're in the business of taking risks, but it's educated risk. It's with enough understanding that the risk is going to be acceptable and that we can deal with or overcome or mitigate the existing risks completely to a sufficient level. Now, in the design world, if something is, say, we're making it and the initial concept calls for a simple polyethylene for a case, and then we find out that the polyethylene's melting temperature isn't is too low for where our products could be used in some circumstances. And by design, we could use a steel or tin or a metal of some sort that has a much higher melting point and can withstand those temperatures. I mean, that's the kind of ways to just avoid the problem altogether, is to design out the possibility of that failure from occurring. Or, and sometimes we do this, is we try to reduce the failure, and we'll talk about that in a moment, but by just changing the possibility of that failure occurring. So there might be variability in our manufacturing process. And so part of this is to reduce the amount of variability, and it lowers the probability of it occurring. And so that's the chance of the possibility of occurring. Another way is to reduce the consequence, is we can create fail-safe systems. Think of a fuse, an electronic system. If we have an overcurrent situation, the fuse trips, shuts off the power. So we avoid the consequence of the system catching on fire, for example, or electrocuting somebody. Some of our design work helps us to avoid risks. And this one's pretty common sense to many of us, I'm sure. The one that caught me by surprise as I was looking into this is that in a larger context, as our organization is exploring new technologies or exploring new markets or exploring new product concepts, that these kinds of decisions need a lot of information about, well, what's the risk? What's the probability of this occurring? What are the consequences of those things occurring? And at some point, those risks, even though they're not fully understood and designed out and tabulated and studied, should trigger, no, that's not the right market for us, or that's not the right product for us. And so part of the process is a way to mitigate the most serious risk that you're dealing with is with mitigation. And, oh yeah, Kent, I just saw your note here. A hierarchy of controls, and we'll. I think there's I know in the safety world, um, uh, there's the inherent risk, and then there's all this cascade or hierarchy of controls and systems to essentially mitigate the risk all the way. And he uses, like you're saying, a range of different tools or techniques to do that. But let me go to the other extreme. Instead of avoiding the risk, we might just accept it. Now, this one is we need information. We need to understand what are the risks, what's the range of risks, and what are their consequences, and so on. And it's one of those things that has to be coherent, or what's the right word, copacetic. It has to be consistent with what our customers and society are saying is an acceptable risk. Just because your organization go, well, that's acceptable risk, but it causes mayhem when it doesn't work, or as it works in the field, that our customers and society are going to say, well, that's not acceptable. And then you are facing a risk with branding. If that's not coherent, or it's not consistent with the rest of the world that our product interacts with, that can be a pretty serious risk in and of itself. So it's one where we say that's acceptable, that when it's even close, when it's near that gray line of is that acceptable or not, that's one worth monitoring. But sometimes we do this in FMEA all the time. We say, well, this risk has a very low probability of occurring, and customers may not even notice it if it does fail. And so if it does occur. And so and the consequence is very, very low. And so we tend not to address those unless our understanding of what the customer expects changes. And so it's it's a part of the process that can be done, but it's not the first one in most cases. You need to have enough information in order to say, yes, that's acceptable. That's below the acceptable risk threshold. And so that's a technique. Now, I think, Kent, you're talking more about reduction or control, right? And so here, if we, and it's I keep going back to FMEA because I see it there is such a natural fit to what we do in FMEA type work, in product design type work, is if we can just eliminate or reduce the probability of occurrence or the severity or the consequences, if we can interrupt those things, or we can design out the possibility of those occurring, we can create systems that are fail safe. All of those kinds of activities help us to reduce the probability or severity of a risk manifesting itself. But part of it also goes beyond just having a failure, but going upstream. And you've heard me talk about this a lot, is making sure that those things that are critical to the reliability or to the safety of your product are coming from a stable, consistent process, the statistical process control and process capability type things. And then even within that, and I know some organizations use critical to quality. I like to use the critical to reliability. That's my personal bias. It sets up a set of plans or structures within our organization and supply chain and manufacturing and call centers, for example, that monitor for uh, elements that either surprise us or were deemed as either low probability and or low severity, but if they occur above those rates that we assumed, we want to know and deal with it. And so a lot of us do this pretty naturally as we're looking at field data, we're looking at prototype testing. we're looking for those manifestations of things that surprise us and don't and that's why we advocate test to failure so often and to get early field failures back into the organization so you can analyze them and use that as a means to quickly monitor and detect unexpected risks that are going to you. Now, part of this also is this responding part. You don't have to wait until something bad happens to respond. Part of the risk management process, this overall framework, is to anticipate this range of risks that are facing you and have an appropriate set of responses that you can implement. You don't have to create the response, you have to implement the response. If you have to take 3 or 4 days to figure out what to do, you're losing a lot of time, and that in and of itself is a risk. As more products go out the door, more things fail in the field, so on. But anticipating that what happens if we have a higher than expected failure rate, or the consequence of a failure is much higher than we expected. Now, most organizations will stop production or do a recall or slow down the availability of the events that lead to the undesired risk. So, but having a clear set of roles and responsibility, who triggers the plant shutdown, who decides, and what information do they need? A product recall, for example. Those kinds of things in some organizations are well spelled out. In other organizations, it's case by case, and just the delay of figuring out what to do is can lead to an increase in the risk that you're facing. All right. The last way, or not, I'm sure there's other ways to deal with risk and mitigate them, but one of them is transference. And it's not something that I'm all that familiar with because I've never been involved with doing it. Yet the more I looked at it, it smacked of, well, we have warranty terms, right? We have a limited warranty on our product. And if you do this, this, and this, you're fine. If you get your iPhone wet, at least the older ones, then they'll say, no, you voided the warranty. And so we mitigated the risk by transferring that. We transferred the consequence of a damaged phone due to water to the customer. And so that was a transference. Now, a lot of people don't like that, right? If you transfer it to somebody and they're not willing to accept that risk, that creates a friction in your brand and in brand loyalty and things like that. So it's to be done with caution. Um, Another one is in supplier contracts. Years and years ago, I got a call from a colleague in IBM asking about how we um, deal with suppliers um, that their product caused the failure. So think of a power supply in a server. So you spend $10,000 on a server. There's a $100 power supply in it. The power supply fails, takes the server down, and you go back to the supplier. They say, "Oh, okay, sorry about that. Here's a new $100 part for you." They replace the broken part, and that's kind of a normal warranty transaction kind of deal, and they're making their product good and stuff like that. We often ask for what was the cause, how do we mitigate it, how do we avoid it in the future, things like that. What IBM was doing was they said, if it's in a $10,000 um, server and your product fails, it's not that you replace the part, is you replace the server. You pay for the $10,000 part of it. And so they were able to emphasize the importance of hitting their reliability targets because the consequence wasn't $100, it was 10,000 if they had a failure, for example, in that example. So that's transferring some of your risk to the suppliers. Some suppliers will be okay with that, others not. That's a negotiation thing. Now, another way, I've seen this happen in a number of organizations where they buy insurance. If we have a catastrophic event where we bought specific insurance for that, so that earthquake taking out your supplier, I don't know how many companies can do that or can afford to do that, but it's another way to transfer part of the control, part of the risk to somebody else. Now, each of these tend to have some cost. and loss of controls for your own process. So it's something to be careful of, as just because you get the full recompense from your suppliers for a power supply failure, it's still the IBM nameplate on the server. So it may have consequences to customer satisfaction. And so it's something to be thought through. Is it worth transferring this to somebody else? All right. So pause for just a second. So I've talked about these elements of a risk management plan and different pieces of it is in this range of terminology that comes around with risk management. Do you have such a plan within your organization? Is it called a risk management plan? All right. All right. Let's, even if you don't, yeah, we had something for products. I agree with you, Frederick. I often see that. And Kent, you have one. And you mentioned, Kent, earlier, I think, your probabilistic risk assessment. So you probably have a complex and or dangerous system going on that you got to deal with. So that in companies like chemical plants, there's always, and it has been for decades, risk management plans of one form or another, for example. Um, and Michael's got a risk management plan. Good. Yeah, mostly complex. The idea here is that some parts of our world deals with this on an ongoing basis. Some of it's regulated, like in the aerospace and medical devices, for example. They tend to be more oversight or encouraged to do, say, hazard analysis and have some form of risk management plan. Yet more and more organizations, more and more studies of what it takes to be successful in the market involves being able to identify and respond to or avoid, mitigate the risks that we're facing. And so you're seeing it more and more standards in parts of our day-to-day work. It's being elevated to a, a means to facilitate communication and prioritization of what we work on. Okay, so there are a few out there, right? So what do we do about this? We're reliability folks, right? Or quality folks or design folks, maintenance. To me, we do a lot of tactical things in general. Now, uh, I've always advocated that our role is not just to do the Weibull analysis. It's to help the rest of the organization understand the meaning of that analysis and where that can help you make decisions. So part of what we do is really in the larger risk management plan is understanding where are these risks and where do we report these. And we do this quite a bit with product failures or prototype failures and understanding the consequences of those failures and dealing with either changing the design or changing the supply chain or the manufacturing process in order to minimize or reduce those product failures. We do a lot of that stuff. Now, what I'm suggesting our role is that we need to connect those types of activities we do to business outcomes and customer outcomes. I have found that understanding the value of identifying, say, a 1% field failure rate is always in context to, well, what's the business and customer outcomes? What's the consequence to them, to those different entities of having this particular failure rate, for example? And if we understand that and can communicate that, then we can help make the decision, is this a problem or not? What's our acceptable risk level? But also, what's the impact to brand? What's the impact to profitability? Those kinds of elements. Is it setting the appropriate warranty set asides? That's a business outcome. setting the right customers' expectations, working with marketing. So part of our role in even just dealing with product failures can be expanded tremendously. And part of it has been a message that we've been doing at Ascendo for quite some time is that we have to add value of what we're doing. And by to do that, we have to influence the decisions that are made within our business, and we have to meet customer expectations. And so part of that is beyond just lowering the failure rate. And so part of our roles and responsibilities, one, expand into understanding, even if it's not written, what's the risk management plan? What are those triggering events that require us to report something, and be very clear about that within the organization. And if there already is a management plan for handling risk, be very clear of what's your role in that, and help enhance that plan so that the appropriate information is moving within your organization as it should. Another part, and this is one that we do pretty much part and parcel to what we do on a regular basis, but I would add that we need to add that risk matrix, right? We may not have every piece of every type of risk within our scope or view of the organization that, say, the C-level or the board level folks are looking at. Yet by using similar tools that's common across the risk management plans and communication techniques, it allows us to talk in the same language in the same way. And just like the FMEA, the risk matrix should be updated regularly, right? And communicated appropriately within our organization. And part of what, and this was one of the things I had a hard time with when I was working with product development teams um, when I was at Hewlett Packard, is I liked hardware. I grew up in creating circuit boards. I was a manufacturing engineer at one point in or two different times in my career, and I like the hardware stuff. I like breaking those kinds of things. The software, the human factors, the other pieces, I don't have as much expertise in, so I tended to shy away from those. That's an opportunity for me, my personal situation, to improve my ability to contribute to the organization by getting up to speed on these other parts of what makes up system reliability. And so, depending on your background, you may have a preference for one area or another. But as we look at and analyze the types of failures and types of risks that we're facing, it's across the system. And it's not just our system reliability or system performance type things, but then it goes obviously into supply chain and manufacturing. So expanding what we include within the risk matrix is one way to then appropriately assess and prioritize which things we need to focus on. Now, one of the risks here is that we focus only on the part that the hardware that we're dealing with, for example. And we may spend a lot of resources getting that hardware to have a very low failure rate, for example, at the expense of robbing resources away from the software team. Basic assessment of what we do day in and day out is often focused at failure rates. So I'm suggesting that we expand that to the areas of software human factors, but also across the life cycle, the design, supply chain, manufacturing, and how we deal with field failures. All of those elements and understand whether our product is working or not are important to the way that we identify and treat risk. And it provides us a way to actually measure or monitor these risks and communicate them. Now, the mitigation review, we spent quite a bit of time on that, so I won't dive into this too much, but a lot of what we do already is the tools that we're using, DFR and SBC, FMEA, and all those kind of things help us to um, understand which mitigation roles are appropriate. And so it allows us to um, actually address the types of risks that our customers are facing, our communities are facing, and deal with those in a proactive way. Now, the last one, and it's common across any types of process or program or framework or whatever, is then do a review step. Is on a regular basis, what's working? Are we making the right decisions? Did we set the acceptable risk at an appropriate way? Was it communicated well? Those kinds of issues or circumstances. And so that's there we go. And so the basic idea is that risk management is a much larger program than product reliability or reliability performance of your systems or availability of your system. We use an appropriate level of tools and techniques to fit into a enterprise risk management program if we're aware of it and we're fit into it and we have a role to play in it. I suggest that we obviously do have a role to play, whether that risk management plan exists or not. If we're finding problems or issues or risks that really do need resources to it, by using the tools that we already have available in the context of a larger risk management view, we can be very, very influential in getting risk mitigated or solved. So, ran over a couple minutes there. Sorry for the system shutting down there for a moment. I don't know what happened there, but thanks for attending. Hopefully, everybody was able to get back online. And in 2 weeks, Chris Jackson's going to do the fourth, I think, final webinar on Monte Carlo Markov chain analysis. And he's promised to provide a bunch of code in R, I believe. And I think he uses MATLAB, so he may have that also. And then watch for announcements for the events that are occurring in December. All right, so I'll hang online if there's any questions. I've been using the chat window. Let me open up the questions panel. I think there's one of those. See if there's anything there. Nothing there. Okay. Well, thanks all for attending and participating. Sorry about the glitch there. I don't know what the deal was with that. I'll have to explore. And hopefully the recording worked. We'll see how robust Zoom is for doing that, and we'll deal with it from there. All right. Well, thanks everybody, and enjoy the rest of your Tuesday, or if you happen to be in Australia, it might be Wednesday already. I'm not sure. We'll talk to you all later.